Finally, we want to take a look at some variants of decision trees. One example are decision trees with categorical features. So here we have a data set that contains weather data, and we want to predict whether to play tennis on a given day or not. Instead of having a comparison of the form xi is smaller or equal than some value, here we have some attribute that is equal to one of its values. It's important to note that categorical features are handled very different by some algorithm variants. In this lecture, we discussed the CART or classification and regression trees, which features binary splits. In ID3, for example, multi-way splits are possible as well. We can also use decision trees for regression. Regression is when our target values are a real value rather than a class. And in this case, instead of computing the mode over an output, we compute the mean in the leaves. The splitting heuristic that is used in decision trees for regression is the mean squared error. You can see an example right here. We have a somewhat noisy sine function that is modeled by a decision tree of depth 2 and one of depth 5. So let's recap. What have we talked about in this lecture? We started out by talking about the interpretation and the procedure to build decision trees. This mostly involved impurity function and different splitting heuristics, including entropy and the Gini index. We also discussed two important concepts in machine learning, one of which is the splitting of data into training, test, and validation set, and the other one is overfitting. And finally, we talked about an extension of decision trees, which are random forests.